Good morning, students. Welcome to the playlist of basic mathematics. And this playlist has been designed for the students who are preparing for the NEET examinations. And the topic which I will be covering through this playlist are trigonometry, quadratic equations, vectors, coordinate geometry, sequence and series, logarithm, differentiation, integration, binomial theorem, and surds and indices. So these are the 10 important topics which I will be covering in the playlist of basic mathematics. And today the chapter is trigonometry, and it is the first session of this chapter. So in this first session, I will be discussing only 2 points, that is what is an angle and what is this trigonometric ratio. So here, in order to save the time, I have already written the definition of angle. So angle is the inclination between the two lines. It is a very simple definition. So here there are two lines, that is, say this is OA and OB. So the inclination between these two lines is theta, and theta is the angle. Now this angle is measured either in degrees or radian. Now let us consider that this is a wooden stick which is pivoted at this point O, and it is rotating in an anti-clockwise direction as indicated by this arrow. Now when this stick is rotating about this point O, then this stick will complete one revolution when it reaches its starting position, that is A. If it starts from this point A and when it reaches this same position, then it will be completing one revolution. And one revolution is equal to 360 degree, and this is equal to 2 pi radians. Okay? So one complete revolution is equal to 360 degree, and this is equal to 2 pi radian. So from this, I have already written here that if 360 degree is equal to 2 pi radian, therefore 180 degree will be equal to pi radian. Or since 180 degree is equal to pi radian, so 1 degree will be equal to pi divided by 180 radian. Now since pi radian is equal to 180 degree, therefore 1 radian will be equal to 180 divided by pi radian. 180 divided by pi degrees. So this is how we can convert the degrees into in radians, and the radians can be converted into degree. Now let us again take this example. This is a stick which is pivoted at this point O, and it is rotating in a circle in the anti-clockwise direction. So when we are moving in the anti-clockwise direction, then the angle is taken as positive, and when angle is taken as positive in the anti-clockwise direction. And if we are measuring the angle in the clockwise direction, then it will be taken as negative. So this is one you can say assumption which we follow. And next important thing is, let us consider that this stick is moving in this anti-clockwise direction about this point O. Now it has moved from this point A to point B in a certain period of time. So let us consider that this distance, that is AB, is S. Now this AB is called the length of this is an arc. If this stick is moving in a circle, then AB will be the arc. So AB is what? It is the length of the arc. Now this length of the arc, here I have denoted this length of the arc as S. So there is one more important formula. This length of the arc is equal to R into theta, where R is the radius of this circular path, and theta is the measure of angle. Now this theta has to be in radians. Okay. Now I will try to just take one example. Let us say this theta is equal to 30 degree. R is equal to, let us say, 4 centimeter. R is equal to 4 centimeter. Then you can be asked that find the value of this length arc. Length of this arc AB. So AB will be equal to, AB is equal to S, and this is equal to R theta. R is 4 centimeter. Now here 30 degrees has to be converted into radians. So we know that 180 degree is equal to pi radian. So 30 degree will be equal to pi divided by 180 into 30. So this is equal to pi by 6. Now, so this is equal to S is equal to R into theta. R is 4 and this theta is 30 degrees. So I have converted it into radians. So this is equal to pi by 6. So this is equal to 2 by 3 pi. Now I have to find the value of this arc in centimeter. So now S is equal to 2 by 3 pi and the value of pi is 3.14. So you can substitute the value of pi as 3.14 in this equation. So I will be getting the length of the arc as 2.3 into 3.14. So if I divide this by, this is equal to 1.0. Approximately it will be, I'm just taking the approximate value, which is equal to 1.05. So it is a slightly less than 1.05, but just for the sake of making you understand how to calculate the length of the arc, I'm just taking an approximate value. So this is equal to 2.10 centimeter. So S is equal to R theta, where theta is, S is equal to R theta and theta is in radians. First thing is, this is important. And once you after putting the value of theta in radians, you will be getting the answer in pi. So in order to find the length of this arc AB, just substitute the value of pi, which is equal to 3.14. And pi is basically what? Pi is also equal to, it is is equal to 22 by 7. So you can also put this value here. You can also put the value of pi as 22 by 7. So by putting this value, we will be able to get the length of this arc. So this was another important point which I just wanted to discuss here. And now, let us come to the next point, that is the trigonometric ratios. So for that, I will be taking one right angle triangle. This is a right angle triangle. Let us say this is A, B and C. So this is a right angle triangle where the angle ABC is equal to 90 degree. Now if I am taking this BC as base, let us say it is B. The length of this base PC is B. The length of this perpendicular AB is, let us say, P. So using the Pythagoras theorem, what is the Pythagoras theorem? That is the AB square plus BC square will be equal to AC square. This is the hypotenuse. This is called the hypotenuse. So the square of this hypotenuse is equal to the square of this perpendicular plus the square of the base. So by this equation, you can first of all you can find the value of this hypotenuse also, or if the hypotenuse is the value of the hypotenuse is given, and let us say the value of this base is given, then you can find the value of perpendicular also. Now now let us say this is an angle theta. So that there are three important trigonometric ratios, that is sin theta. The sin theta will be equal to is perpendicular divided by hypotenuse. Then cos theta is equal to base upon hypotenuse. And there is one more trigonometric function, which is tan theta, which is equal to perpendicular upon base. Okay. So from here, the sin theta will be equal to what? This will be if this is perpendicular upon hypotenuse, so sin theta will be equal to what? P upon, let us say this hypotenuse is h, so it will be equal to P upon h. Similarly, cos theta will be equal to B upon h, and tan theta will be equal to perpendicular upon B, that is P upon B. Okay. So these are the three important trigonometric ratios, and the reciprocal. Now let us discuss the reciprocal of these three trigonometric ratios. The reciprocal of sin theta is cosec theta. The reciprocal of cos theta is sec theta, and the reciprocal of tan theta is cot theta. Okay, that is cosec theta will be equal to hypotenuse upon perpendicular, or it will be h upon p. Sec theta will be equal to hypotenuse upon base, and that will be equal to h upon b. And cot theta is the reciprocal of tan theta. So cot theta will be equal to base upon perpendicular, so it will be equal to b upon p. So this was the short session on the angle and trigonometric ratios. And in the next session, that is in the session number 2, I will be continuing with this trigonometric ratios. And if the time permits, we will also discuss about the these trigonometric formulas. So till then, have a nice day. Bye.